Hello, everyone. My name is Zhen Liu. I'm a master student in Clark University, and I'm glad to be here to share our breaking through in GIS methodology. And my topic is stratified random sampling generates the total operating characteristic with application to floor mapping. So first, I want to thank the Allen Bailey Sussman Funding and the National Science Foundation to support our research. Also, thanks the CloudStreet for the data and the help to develop the method. As we all know that remote sensing is an important source for the floor mapping, and water index is a common and efficient way to diagnose the floods. Also, there are various indices for the floor mapping. So in many assays, researchers are inclined to use the accuracy measures to compare the multiple indices. What they do is, first, they apply a threshold to the continuous index to get a diagnosis, and then compare the diagnosis to the reference to get the contingency table. And at last, calculate the accuracy measures using the 4 central entries in the contingency table. Also, we call it the confusion matrix. However, there are various ways to select a threshold, and the selection can influence the results substantially. So the use of a single threshold insufficiently represents the performance of the index. Total operating characteristic is a statistical tool to compare the index variables to a binary variable. It considers multiple thresholds, and the total operating characteristic keeps the main properties of the relative operating characteristic, which is also a tool to evaluate an index. And the TOC has more important features. Previously, the data to generate a TOC curve is derived from the sensors or a simple random sample. So the stratified random sampling is more efficient than the simple random sampling. So in the assay, we combine the TOC and the stratified random sample, and this methodology can be applied in various fields like medicine or the floor mapping. In this presentation, I'm going to present how we construct the TOC curve from a stratified random sample, how we use this methodology to evaluate multiple indices, and the software developed by me for the TOC application. First, I'm going to use an example to show how we construct the TOC curve from the stratified random sample. In this example, there are 14 observations, and each observation belongs to one of 3 strata. And the strata here are ranked according to the suspicion of water from high to low. And the index variable here is the elevation, and the reference shows whether the water is present or absent. Our assumption is low elevation indicates high suspicion of water, and we are going to use the TOC curve to assess the diagnostic ability of the elevation. First, TOC considers several thresholds. So we select the unique values in the index variable as the potential thresholds. Then we rank them according to the assumption. We rank the low elevation first and create the index intervals with ranking. The observation which falls into the index interval will be ranked as the corresponding ranking, like this. Then we use the equation 1 to calculate the weight for each stratum, and the observation will be weighted by the stratum it belongs to. The next animation shows how we use the equation 2 and 3 to calculate the coordinates of the points on the TOC curve. The horizontal coordinate indicates the diagnosed quantity of presence, which is the sum of the hits and false alarms, and we assign it as D. And the vertical coordinate indicates the hits, and we assign it as H. D and H end at the size of extent and the size of estimated abundance, which will show at the end of the horizontal axis and the vertical axis. And we call abundance here as the estimated abundance because the result is estimated by the sample data. And the size of extent here is not the sample data size, it's the size of the whole study area. Also, the space for TOC is not the whole coordinated zone. From the contingency table, we know D and H has its own range, and we can create 4 boundaries based on these equations. And notice that the left boundary and the right boundary, the slopes of those 2 boundaries are not 45 degrees in this diagram, because we make the length of the vertical axis and the horizontal axis equal for the visual clarity. Then we connect all TOC points and join the first point with the point at the origin, and it creates the TOC curve. The diagram on the right is the product from my software, TOC Curve Generator. Previously, researchers will use a diagonal line across the TOC space as a baseline for a comparison and named it as the uniform baseline. But with the strata information, we can generate a TOC curve for strata as a baseline. The difference between the TOC curve for indices and the TOC curve for strata is that we rank the observation according to its stratum. So the animation here shows how we construct the TOC curve for strata. And the TOC curve for strata is more relevant and informative than the uniform baseline. Also, TOC provides several useful measures. Like first, each point on the TOC curve reveals 4 central entries in the contingency table. And it's important for the researchers who want to calculate the accuracy measures as the thresholds vary. And the area under the TOC curve summarizes the performance of the index across the whole TOC space. It is calculated as the area under the curve in the TOC space divided by the area of the whole TOC space. Also, the point where the diagnosed quantity of presence equals the estimated abundance is important too. This point shows how allocation errors like false alarms and misses affect the result. It is the intersection of the TOC curve and the vertical line across the upper left corner of the TOC space. And we draw it as the star-shaped point on the TOC curve. Then we apply this methodology to a real floor mapping case. We sample 200 points in 3 strata and use this methodology to evaluate the performances of 3 water indices, NDVI, MNDWI, and MNDWI. From the result, we can see the TOC curves for indices are all above the baselines. And the difference between the TOC curves for indices and the baseline shows how much the remote sensing data boosts the diagnostic ability. Also, from the shape of TOC curves, AUC, and the vertical coordinate of the star-shaped point, we know MNDWI performs the best in 3 water indices. And also from zoom in, we can see the TOC curve for the NDVI is above the NDWI around the star-shaped point, which indicates NDVI is less affected by the allocation error than NDWI in this case. Then the thresholds around the star-shaped points are really important for researchers who want to diagnose the correct quantity. To make the TOC application convenient, I developed a software named the TOC Curve Generator, and it has several features. First, it can input data in various formats, like TIFF, RST, text, and Excel. Also, it can set weights according to the strata information. What the user needs to do is just type in the size of each stratum, and the program will generate the diagram using our methodology. Also, it can show multiple TOC curves in one figure for users who want to compare the multiple indices. And users can label the points with the threshold values and export it for their research or the paper. So all the software and documents can be downloaded at this website for free. our conclusions are first, scientists should make the full use of the TOC curves to evaluate the performances of the index. Also, we recommend scientists to download the software written by me for the TOC application. So we will be grateful if you can give us some advice or feedback on our software or the method. Thank you for your listening.
Great. Thank you, Zhen Liu, for the great work. So any question to Zhen? So if I do have questions, so you mentioned actually when we read the article, we are very interested about the flood mapping part. Could you elaborate a little bit more about the stratified random sampling versus the the traditional random sampling? Maybe I miss that part. Yeah. So maybe elaborate a little bit more about this part. Yeah.
Yes. So we use the stratified random sampling in our assay. And the first reason is we can put more sample points in the area that we are interested in, like the floods for the strata 2, its land was flooded by the floods before the 2019. So this area is important for the decision makers to see whether it will be floods again. So we can put more points on this strata, and then we can show more details in our TOC curves. So that's why we use the stratified random sampling here, not the traditional random sample.
So does that relate to like imbalanced sampling?
Yeah.
When we do classification. Okay.
Make the results more informative to the decision makers.
Okay. Yeah, that makes sense. Thank you.